Today we're going to be writing our very own terminal-based Rust application. And to build our own terminal user interface application, we're going to be using a library called Ratatui. And like any great Rust project, we're going to start off by doing a cargo new and the name of our project. I'm going to call this, we're going to be making a to-do app. Something to help us organize our chaotic lives, so to speak. So we're going to call this, we're going to do a cargo new. I'll call this Toodles. I'll call this application Toodles. Feel free to call yours whatever you want. And that should generate a new project for us. So if I actually go to this new directory, run, we can see that we have a new project built here. Now we're going to start by getting the initial project set up with the proper dependencies and everything like that. So let's jump into our favorite editor. We're gonna head over to the cargo toml and we're just gonna add a few dependencies here. So the first dependency we're gonna be adding is the Ratatui library itself. I'm currently gonna be adding version 0.29 with the all the widgets feature. We're also going to be adding the color dependency to this project. This is sort of part of Ratatui's application design and helps return useful error messages. So now that we have our dependencies set up, I should be able to jump over into the main section. And we're going to get the initial sort of project setup code. So to start this off, we're gonna do is by initializing the color module. All we gotta do is run a color install. Now that's gonna sort of, that might pop up a little weird error message for you, but you should be able just to sort of append, add a return statement to this function. And we can actually change this to, I'm actually gonna change this to result. We actually want to change this to the color result. I believe it's this one here. Just going to return nothing in there. And just to fill this out, we'll just pop an OK with an empty parentheses at the end of this. All right, so we got color installed. The first thing we're going to be calling is we're going to be setting up a terminal variable from the Ratatui module. We're going to call the init method. This is going to return the terminal type. Oop, just better rename that. Terminal. So we're actually going to be adding a statement. We're going to be adding the Ratatui restore statement to the end of the line. This is going to be responsible for sort of just restoring the terminal back to its original state. So we'll call the terminal, we'll call it Ratatui restore, and now we're going to add the function that's going to be responsible for essentially the main loop of this program. So let's just drop down here. We're going to add another function. We're just going to call this run. Inside this function, we're just going to add mute terminal. And we're going to give this the type, the default terminal from Ratatui. We're also going to want to return a result, sort of like we did up here. So I'm just going to grab this, jump back down here, throw that in here. Let's add the return line. And I'm just going to clean this up, return an OK for now, just to sort of prevent the error warnings for now. And the run method is essentially going to be our main loop, and it's going to return a result. So we're actually going to jump back up here. We're going to say let result equals run, our new run method. We're going to give it the terminal we declared up here. Oops, switch this. And the result is actually what we're going to be returning instead of the OK. So now that I can replace this with result, just kind of like that. And we're slowly coming together. We declare the terminal. We're going to be doing our run method. This is where the application is going to run. It's going to return a result, and the result will eventually be returned to the terminal when the application ends. Now let's deal with the loop. So let's just add a good old loop statement here. The first thing I want to set up is sort of like a key binding to handle exiting the program. As this loop is going to be responsible for both rendering and input handling. Spelled that wrong. This is going to be a perfect place just to set up this key binding real quick. And to get started with the key handling, what I'm going to do is I'm just going to create an if let statement, and I'm going to set if let event equals key, and I'll just put a K for the key in there for now. And we're going to be calling event, the event module, the Ratatui event module. We're going to be calling the read method. And inside here, we're going to be able to sort of handle key presses. Now, this is going to look a little bit funky until we set this up. So I'm actually going to change the name of this variable to key, and we're going to drop a match statement right here. We're going to be matching the key.code. I'm going to fill in the arms here with my language server provider, and that's a little verbose, so I'm just going to chop some of this down here. We'll set up a little default statement for the match, and if key code equals escape, we can break the loop and also break the somewhat distracting diagnostic messages here. So I'll just add a return or a break with an OK. We'll just break right here. When we press the escape key, it'll break the loop, and that will return OK, and we'll exit the program. And I can just kind of run this and see what happens. Oops, let's move into the proper directory. Run this. Compiles. Loops. When I press the escape key, it exits. All right. Run early, run often. It's good to know if you're going to run into an issue before you get too far into the project. Now let's just set up the rendering method here. We're going to drop down. We're going to quickly create a new function. Let's center the line here. We'll just call this for now render. It's actually going to take something called the frame object. We're going to have to make this mutable. It's going to be the Ratatui frame type. Now to actually start drawing, we're going to use the terminal parameter given to this method. We're going to call terminal.draw, and I'm actually going to give it the render method I declared down below. All right, now if I jump down here, we can actually get started rendering to the screen. Just for fun, we'll just start things off. We're going to use the paragraph widget. I'm going to call paragraph new, give it some text. We'll say hello from application. I'm going to call the render method directly on this widget itself. I'm going to give it the frame.area. This is all going to be sorted out later, and we're going to give it the frame.bufferMute. Now there's different ways to render stuff in this. There's sort of different patterns to render things in this library, and this is just sort of one of them. You can call the render method on the widget itself. So if I run this, you'll see hello from application, completely spelled wrong, but it is there. And we have just started building our own terminal user interface. Now this is kind of where the fun just begins. All right, to get started, we are building a to-do application. So let's start building. Oh, I can get rid of this. Let's start setting up the data structures that are going to be needed to run this application itself. And it's not going to be too tricky. We're going to start with a structure here. We're going to call this to-do. We'll just call this to-do item. Since we're making a to-do list, this will be one of the list items. One of the first fields we're going to be adding here is done. We're going to add an is done Boolean, something that's going to signify, is the to-do item sort of finished or not. You could call this whatever: is finished, is done, is complete, whatever you need. And of course, we're going to need some sort of description data along with this to-do item, something to display sort of what it is we're actually going to be to-doing. So we got our structure here, the to-do item. Now let's create another structure to sort of store the state of the application itself. I guess you could think it's essentially just going to at this point just hold a list of to-do items for us. So we'll create a new structure. We'll call this app state or something. Maybe you want to call it, I don't know, you call it whatever you need. I mean, it's really just holding a list of to-do items. You know, this might be a not necessary step, but so we'll just add a field. I'll just call it items for now. It's going to be a vector of to-do items. I think I'll going to add a few convenience macros here. So let's add a default. I think we can add a default. I think I could add a default here too. I'm not sure. Yeah, we can do a default there. And we'll sort of add macros as we go. So now we have a data type to represent like a single item on the to-do list. We have a data structure that's just going to hold the state of the application, which essentially right now is just a list of items, a list of our to-do items. Now let's set up the Ratatui library to actually handle and display our application state. And then we can add in the key handlers to create to-do items, remove to-do items, select to-do items, and so on and so forth. All right, now that we have our main data structure, we can actually start bringing that into our application. Let's get rid of this print line. We're gonna add a let state equals app state. We'll do the default method that we set up. We're going to be adding the app state to our run method also. We're going to be passing this in. So let's pass it in. We'll call this the app state. We'll make this a mutable version of the app state. And we'll actually be giving the app state also to our render method here. I'll just add that here. I think I can actually drop the mutable part, not sure. Just set that up like that for now and we'll see what happens. Let's give our state 2. This has to be mutable as well. Can I do the app mute like this? I forgot to set it up here. Mutable. That should be good like that. Let's jump down to the render method here. I believe I can just pass the app state here like this as well. Oh yeah, I'm actually going to call this a little bit differently since I'm giving this another parameter. So we can actually turn this into a closure, I believe they call it. And I'll call the render method sort of like this. Get rid of this. And this is actually going to be F instead of the frame. And that looks good. I didn't need any of that mutating stuff. All right, so we're passing the app state to our run method, which we're going to be able to affect it with when we start handling user input and stuff like that. And we're also passing it to our render method. So now we're going to be able to sort of render the application state to the interface. And since the app state is sort of just a glorified list at this point, and we are writing a to-do app, the Ratatui list widget is going to come in just perfectly. Now, Ratatui has some great documentation here, and you can just sort of go to different parts of the documentation to sort of check out the examples. There's discussions on different concepts about rendering, application patterns, the backends. Lots of great stuff to use, and we'll be sort of using the list widget here to power our to-do list. Now to create now we're going to be creating a sort of nice looking user interface, maybe like this application here. But to start, it's going to kind of look pretty bare bones for now. But there's a little bit we can do just to get started. We're going to get started with Ratatouille's sort of layout system. Now, the way things are sort of laid out in the user interface is done with their layout API, which is fairly interesting. It's very well done. I really do enjoy it. I think I can go down the concept section, and it sort of like explains everything. I'm not going to be reading all of this, but just kind of showing you in the documentation where you're going to be looking for dealing with the layouts and stuff like that. This is super important, creating the beautiful looking user interfaces. And we're kind of just going to do something like this, like a layout default. We'll do something like that. So let's do, we're going to actually be adding a border. So let's call this let border area equals layout. That's the Ratatui layout. We're going to do a vertical. There's vertical margin, but that's not what we're doing here. We're going to make this a vertical, and here you have to give it a list of constraints, and I'm actually going to be giving it just one constraint. So I'm going to add a constraint enum. This is going to be just the fill. This is going to be the fill constraint. I'm just going to add one for now. We're going to pop a margin on here. We're going to give this a margin of 1. And I'm going to call, on this one, I'm going to call areas. I'm going to do the frame.area, which is the frame of the application itself that we pass into the method. And I actually want to wrap this in square brackets. Now you're going to see the demonstration of this border area layout that we've defined here. And a good way to demonstrate that is with the block widget. Now the block with it is, as you might have guessed, adds a sort of a block to the user interface. And you're going to see what that looks like. So we're going to do a bordered block. We're going to do bordered type. We're going to add rounded borders, because why would you do anything different? I can actually use my LSP to replace the qualifier path just to shorten up the enum on that one. Let's give it a foreground color. We're going to give it a foreground color. Let's add a color. I believe that's the Ratatouille style color we're going to be looking at. And we'll do yellow. Maybe we'll just do yellow or something. I don't know. We'll start that off with that. And on the widget itself, we can just call render again. I'm just going to render. I'm going to give it the border area we defined up top. And I'm going to give it the frame.bufferMute. Let's post that and we'll see what that looks like. All right. Now you can see there's a border on the application. The hello application at the top's kind of distracting. So let's just cancel this out for now. Restart that. And you can see we get a little border, right? We get a little border. So we declared a little vertical layout up here. And then we give that to the block widget. And then you can kind of see it's wrapping a little border there. And that's going to be the start of our user interface. We'll just add a nice little border for now. And now what the widget that we're going to be using is the list widget. And as you might have also guessed, if you've ever dealt with user interfaces, the list widget is going to be responsible for rendering our list. So to start this off, when you create, well, we'll fill in this middle new part in a second. Let's start with doing a render. So we're going to start with just a render. We're going to start with just a render. If I could get back here, render. We'll put this in the, we're going to have to define another area. We're actually going to define another area. So I'm just going to copy this. I'm going to add it down here because I'm actually going to be taking an area from, well, you know what? Let's do this a little bit different. Let's just render this in the border area, and I'll show you what that looks like before we go. Frame.bufferMute. Let's handle the items here. So we're going to do app state. We're going to take the items from our list. We're actually going to be mapping it. So I'm going to call them iter. We're going to map the list into a different list. You'll see that. So we'll add a little closure here. We're going to map the called a list item, which goes in the list. We're going to generate a list item from the to-do item, but it's going to be the to item's description for now. And it does want actually a clone of it, but I think I can just pass. Did I get that wrong? Hold on. Let's check this out. I should have did a string clone. So let's go back. I'll save that. Jump over here. Add a clone. Oops. Picked the wrong thing. Clone. There you are. Now we probably won't see much yet, right? So you'll notice the color of the border did change. That's because there's the list is actually overlapping. It's overlapping the block border, the yellow block border that we put up. So I'm actually going to be doing this. I'm actually going to do this the original way I wanted to. I'm going to add another sort of inner area here. Let's call this the, I don't know, we'll call this the inner area for now. Definitely try to do appropriate names. And it's actually going to be the same thing, but it's going to be splitting the border area itself. There's different ways to do area layouts. I'm just going to kind of do it like this for now. And here we'll give it the inner. And then you'll notice that the block when I start it, oop, I forgot to. Okay, that's why I actually accidentally deleted this. How did I delete this? Let's add that back. Color, yellow. Let's do the appropriate demonstration now. There we go. You can't see the list. The border's back to yellow. All right, so yeah, now we can't really see much of the list right yet because we don't actually have any items in the list yet. So let's just add 2 items to the list. We'll call state.items. We're gonna just add, let's go to do item. I'll do it like, I'll create the item like this so I can fill in the struct itself. We'll set is done equal to false, and then we'll set description equal to finish. Oh, this is going to be a string, so we'll do a string from finish application. Now we can actually push a few of these just for demonstration purposes. All right. And it's going to have, so now we have 3 items in the list. Finish application. They're currently printing. And now we can at least see the start of our application. You know, we can run early, we can run often, make sure there's no mistakes before we get too far into the code. I'm not using Git with this, but I do recommend to use Git. And every time you sort of get something in a working order, you know, lay down a Git commit. So now that we can actually display items from the list, we'll do 2 things. We'll set up the keybinds so that we can add new to-do items, take away old to-do items, and then selecting different to-do items through the list. So we have no interactivity in this application right now. I can't select any items on the list. So we're going to get into that. We're going to get into list states. So next up, let's start doing some of the key handling. And we'll start this off by writing this here, and then we're going to move this sort of into its own separate helper method after. So we're going to be handling another event, another key code event, and we're actually going to be handling the char event. So this is going to happen when a user presses a character on the keyboard, essentially. And we're going to be catching these characters. Now let's set up the list state. The list state is going to essentially store the state of the list of the selected items so that the user can scroll essentially up and down the list, select items in the list and stuff like that. So we're going to define in our app state called the list state. And the way this is going to work, we're going to change the render method here a little bit different. I should be able, I think it's frame render stateful widget. We'll have to define a name for this widget. So let's call this let list equals that. We'll jump down here, change this to the list. The area is going to be the inner area, and the state is going to be the app state dot list state. And this actually has to be mutable. And this is a mistake because I actually have the render method still on that. I should be able to do this. Oh, that's right. I'm going to have to actually set this as mutable up here. So the app state has to be given as mutable as well to the render method due to the render stateful widget setup. Okay, so that should be all in working order. So now there's a list state. It's going to be sort of rendered with the list, right? We can't really see anything with that yet. And here's why. We're going to have to handle a few characters that the user might be pressing. So let's go ahead. I'm going to match. I should be able to match the char itself. I'll add a default here. And let's catch a few characters. The first one going to be the J key. And the J key is simply going to call app state, list state, select next. Now let's start that. And as you can see, we'll set K to select previous. And we're gonna add a row highlight style to the list itself. So, oops. So maybe we'll just add row. Oh, I got the wrong name. It should be highlight style. We'll give this a style. Just for now, we'll give this a style default with a foreground, some color, maybe green. All right, and in theory, when I start it and I press the J key, it's going to select next on the list state. Let's scroll back up here. If I press K, it's going to go select previous. If I press J, it's going to select next. So now we got, and you can see it's turning green. Maybe I'll blow that up a little bit. We should be able to add also a highlight symbol if we need to. Can be useful to further signify where we are on the list. There we go, we can see that pretty clear. All right, now we've started to get keybind functionality, user interactivity. We can sort of just select between the list, not doing much right yet, but we're definitely on our way. All right, up next, we should be able to add the delete functionality to this. So I'm gonna grab this, paste that up here. I'll change this to a capital D. I'm going to use a capital D instead of just a D in case the user accidentally presses D and we don't just delete their stuff. Now, when we press the D key, we actually going to want to get the selected item from the app states list. So we're going to call app list state selected. This is, we're going to return an option. So we're going to want to turn this into an iflet, which I'm going to do with my LSP here. And this is actually kind of weird. Let's change this to iflet. And this is actually going to be selected index. So I'll just call this index. So if we have a selected index, what we're essentially going to do is we're going to remove from the items, from our items list, right at the index. Now, if we go back in here and I select something, press D, okay, so it actually deleted it. Since they're all the same name, since they all have the same description, let's call this descript 1. I'll yank that, go down here, VIB, paste that in, call that 2, down here, VIB, paste that in, call that 3, 4, we'll just call that 4. And now if I delete 2, 2's gone, 4's gone. I can delete 1, so it seems to be deleting the appropriate one. So I think delete's good. I think we got delete good. We got the deleted. Now we're just going to be handling adding a new item to the list, which is going to be a little more involved. And there's many different ways to do this, but I'm just going to kind of do this in this way. So we're going to set up another Boolean. We'll call this is add new. We'll set that as a Boolean. I want this to be false when I set up the app state. So I'll just declare it false here. And we're going to be using our new Boolean to sort of determine how we're going to be rendering the application and how we're going to be handling the key bindings. And you'll see that as we go. So let's start. If the user presses the capital A key, switch that, we'll set the app states is add new equal to true. And then that's going to sort of determine what's going to happen when we press the key binds and things of that nature. Now, this is probably appropriate time to sort of start breaking this down into separate methods. So let's create a new function just to separate this out a little bit. Start the function. I'm going to call this handle key. I want to give it the key event. So we're going to give this a key event. And I also want to give it the app state as well. I'll switch the name of this to key. I'll come up here, grab everything in here, jump down here, paste it here, and we're going to want to return something from this method to signal breaking the loop. So we'll just return a Boolean. I'll just set true. I'll return true when I want to break the loop, false when I don't want to break the loop. And I should be able to replace this with if handle key. I'll give it the key event and the app state, and then here I can call break. Should be able to get rid of this, and in theory, we should have all of the wonderful keybinds that we set earlier. And I can still delete it. Okay. Now I definitely wanted to clean this up a little bit because we're going to be adding a little bit to this method, because we're going to add another if statement. Essentially, if app state dot is add new, we're going to be handling the keys different, and then so we'll add another else block. This will fit in the else block. Put that here, and we're going to be doing a similar match statement. So let's add a new method, just like we did for the handle key event, but it's going to be handle add new, just because I'm running out of method names. We're also going to return a Boolean on this as well, because we're going to have to signal when we want to sort of exit the handle adding the new mode. And then so we'll change app state dot is add new equal to false when this escapes, when this returns true. And now, depending on if we're adding new or not, we're going to be handling the key presses different, and we're going to have to do the same pattern here essentially for the render method also. So for now, I'm just going to drop this down here. If we're rendering new, I'll get rid of this else block for now. If we're rendering the new, what we're going to do is we'll add a paragraph, and it's just going to currently display this. And in the key handling method, for when we're in the add new mode, we'll grab an event from down here. I'm going to add a default event just in case. And we're going to be handling the escape key and also the enter key in exactly the same way. And in theory, if I press Shift A, that's going to pop up out there. If I press escape, it'll go away. Shift A, if I press enter, it'll go away. So now we're kind of seeing the start of handling two different types of rendering and key events. Now we're going to be actually adding another variable to our app state, and this is going to store the current input value. We'll call it input value for the new description of the to-do item we're going to be inputting. I'll set this to string for now. That should be an empty string. We'll use this down here. App state input value. We're going to just send the borrow for that. Did I do that wrong? I'll just do an as string slice here. And probably just do that the same here as string slice, I believe I can do. Let's clean that up a bit. All right, now it's not going to print anything yet. If I press sort of the add thing, you're not going to see anything, and the magic's going to happen sort of up here now. We're going to add some sort of input handling for adding to our description. Now let's just add a quick block actually here. We're We're gonna add a block widget, so when this thing pops up, it's going to be pretty evident. Block, let's do block. Let's do block, bordered, I believe it was. Border type rounded. Let's just see what that looks like. Okay, that pops up there. I'm gonna add a little bit of padding here. Should be able to padding, and there should be padding. Uniform 1. We'll add a foreground color of green. When I start that, okay, everything changes green. We'll be clearing that up in a second. Let's go back to our key handling method for a second here. And now we're gonna have to handle the char events when we are in the add new mode. And this is actually gonna be fairly straightforward. So when a char event comes in, we're simply going to add that to the input value. I believe I can just push a char like so. And then we'll see if I go into input mode and start pushing chars, it starts writing like this. Now this looks all weird because it's overwriting the list down below, but we're gonna soon straighten that out. Before we do that, let's handle pressing the backspace key events, and that's going to be straightforward as well. We're going to get the input value from the app state once again, and we're going to pop, it should be the pop method, I believe. Now let's just test that out. Let's go into insert mode. So now if I press backspace, it goes back, right? It's going back, forward, more characters, back. Okay, now we're starting. Now let's just quickly do something about the display. So if app state is add new, we're sort of going to render this, but now, so just quickly, I'm just going to sort of throw all of this into an if block down here for now. And we'll clean that up later into a separate method. But essentially now if I press A, this is going to pop up. I can sort of start adding some stuff here. I can take away. And we've started our little bit of functionality here. Now, when we return from the add new method, let's go to where this is being used right here. We're currently handling the escape key and the enter key as returning true for now. We might want to update this into an enum so we can return maybe 3 separate values instead of just a bool. Let's do that real quick because it's just super easy to do. Let's just rock an enum here. We'll call this form action. We'll define 3 actions, none, submit, and escape. We'll go back down to our handle add new method. It's going to return our form action instead. That should give us some errors. Let's handle the errors as they come up here. Not that one yet. So instead of returning false, I'm going to return none. Instead of returning true on enter, we're going to return, so this is actually not this none, returning the form action none. Up here, we're going to return form action submit. And here, we're actually going to return the escape value. And that's just going to sort of let us handle this a little bit different. So let's change this to a match statement. Let's grab this sort of down here, grab all that, pop that here, fill in the blanks, you can get rid of this stuff here. So when they press the escape key, it's pretty straightforward. We're just going to app state is add new equals false. We'll also clear the string, the input value, since they're just sort of going to be escaping out and they don't want to use that value. On none, we're not going to be doing anything. I guess I'll just leave that blank for now. And on submit, it's going to be kind of like what we've done here, except before we clear the method, we're actually going to be adding this to the list. We're going to essentially add this to the list. So we'll create a new to-do item. I'll fill in the little structure here. Is done will be false because it's a new item. The description is going to match the input value. And I think we need to clone that or something. Okay, so now if I add new, type in a bunch of stuff, new to-do item, and I press enter, you'll see the new to-do item has been added to the list. If I go into this and I press escape, nothing is added to the list. And now I can add to-do items to the list. I can remove to-do items from the list, and I can read the items and select between the items at my leisure. So now we got the basic functionality of the application, just sort of being able to create our new to-do list. So let's get rid of, at the start, these examples. We don't really need those in here anymore. The start of the method will just sort of look like this for now. I can press A, it's gonna jump here. It's not very intuitive because there's a lot we haven't added to this, but a lot of this video is just to sort of get you started into doing this stuff, get you started into Ratatui, get you started into the terminal user interface. But now I can add just new stuff at my leisure. Hello world. Let's do something to show when a item on the to-do list is complete. There's a few things we got to work out too. So when I press A, the box looks all kind of weird. Let's just kind of fix that up real quick. Oops. Accidentally got rid of the thing. Let's go back over to doodles. Let's just make sure I got that. Okay. Let's head down into the render method. The layout was just not right. So essentially, I'm going to define the border area up at the top here. That should be enough to do it. We'll change the render area of the paragraph here to the border area. I think that might look a little... There we go. So it turns green, at least, when I press this. Now let's add, actually, a title to the paragraph block, to the block we're doing here. There's a nice title method I could do. We'll call this input description, something like that. We can just add a title to the top of the block. Press A, input description. It's kind of over there. We can actually center the title, I believe. Let's into span, something like span, to span, centered line, into centered line. That should put it right in the middle for us. Input description. I can input, I can press enter. There's our new item. I'll press shift A again. Hello, enter. There's our new item. Pick between them. All right, looking a little bit better there. Now let's handle items that have already been sort of to-do, that have been done. Let's add another handling to our key event. Now, this is when we're in list mode, not on the add new mode. We're gonna add a key event to the list mode, I guess you could think of. Maybe I should change the name of this method, but when we press the enter key, I guess I'll just do enter for now. That will change it to is done or not. We'll toggle if it's done or not. So I can actually get the selected to-do item. I can call app state items. Oops, items. Is there a get at index essentially? That returns a option, so we'll break that option down. Can I do is with? I think there's a with. I'll turn this into an if let sum. Put that there. Change this to replace with an if let. That should give me the item itself. And I think I would need to make this mutable somehow, but let's call item dot is done equals true, something like that. It should complain because it's not mutable. Can I change it here? Yes, maybe. No. Is it at mute here? Oh, I called the wrong method. I gotta call get mute. Then I can set it to true. Always forget about that one. So actually, instead of setting it to true, let's set it to the opposite of is done for now, because I want to be able to toggle this off and on. So I think I can just set it to the reverse with the exclamation bang. So when I press enter, we change if the item is done or not. Now, how could we display that? Let's head down into our method here and add some braces to this closure so we can sort of change the description a little bit here. I'm gonna VIB. I'm gonna separate this into a variable, and I'm actually gonna be adding an if statement right here. If X is done, else, if X is done, it'll equal this, else, we'll change that to this. Gotta get rid of these to signify the return value. So if it's done, can I toSpan dot underlined, and then maybe just toSpan here, and then essentially let's add item 1, let's add item 2, and if I do it, it actually underlines it, toggles the underline or not, but that's not exactly what I wanted. I wanted crossed out and not underlined, so let's try that again. I'll add item 1, I'll add item 2, and if to do it, it crosses it out. Press enter, crosses out. Press enter, brings it back. All right, let's blow that up a little bit. So now depending on the state of the to-do item itself, it's actually gonna render differently. And we can now press the enter key, just sort of like we've done here, to change the state of the to-do item, the is done boolean. And yeah, and then we can see item 1's crossed out, that one's too, item 1's crossed out. Why don't we add a little border to the top of our block here? This might be a good time to maybe do a quick refactoring. If I do a VIB, grab all of this, extract this into a function. We'll call this, I'll rename this Control F CIW render list. I'll just break the render down into that a little bit. Let's break this out into a separate method. VI shift B, extract into another function, rename this, Control F CIW. Let's call this render input form. It's the input form, I guess, for now. All right, so our render method will render 2 different methods depending on if we're in the add new. This is rendering the input form. This is rendering the list. Let's add a little bit of a title to our application in the render list part. We'll call this, I'll call it the name of the application, but you could call it to-do list or whatever. To-doodles. Let's get that to the center, shall we? Into center line. Toodles. Item 1, and select that. Item 2, we can select that. Got a little bit of styling, got a little bit of the border. Now, obviously not perfect. We can't save any of the items yet to the file system. There's a lot to be desired in terms of building a graphical user interface and stuff like that. Here's, an example. Let's head over just quickly to an example of maybe a fully completed, what I would add sort of from here. Maybe like the line at the bottom there to show the key bindings, maybe a little help window you can press, like when you press the exclamation or the question mark, you can pop up a little help menu. There's sort of like a lot of other little things you can add to the application to make it look better and behave appropriately. But You know, just as a beginner sort of walkthrough into creating your own terminal user interface application with Rust, with the Ratatui library, this should sort of get you off your feet, so to speak. And, you know, where would you go from here? Maybe polish up your to-do app, make it more intuitive, show the key bindings that you can press, make the input form look a little nicer. And yeah, there's definitely a lot you can do, but as a starting point, you know, if you did follow along and build this applications, you sort of now have your own to-do list, and you would want to sort of learn how to serialize the data from the list, maybe into the file system, so you can load the list back up when you start the application, and so on and so forth. But that is just a brief little coding introduction, a little coding run through, very quick and dirty, of how you can build your own terminal user interface application.